Hello, statistics students. Today's learning target is to determine if a situation is binomial or not. We will then practice calculating binomial probabilities, followed with finding the expected value and standard deviation of a binomial distribution. So if you look at the handout or the screen, there are four things to be binomial. You need two outcomes, which we typically say success or failure. The observations need to be independent. The probability of success needs to be the same for each observation. And the last thing is there needs to be a fixed number of observations. So if we look at this example on page 378 of your textbook, we want to see if these situations are binomial or not. So for part A, the waitstaff at a small restaurant consists of 5 people who identify as males and 8 as females. They write their names on a slip of paper, and their boss chooses 4 people at random to work overtime on a holiday weekend. We count the number of females who were chosen. So there are two outcomes, either female or male is chosen. We have to determine if the probability of success is the same and if the observations are independent, and those two are very much related. So if we look at part A, the probability of picking a female on the first pick, there are 5 and 8 people, so there's a total of 13, and the chance of picking a female would be 8 out of 13. The probability that the next person is a female is going to change because we already picked a female, so it'll either be 8 out of 12 or 7 out of 12, depending on who was chosen first. So these events are not independent, and the probability is not constant. Therefore, part A is not binomial. Let's take a look at letter B. In the United States, about 1 in every 90 pregnant women gives birth to twins. We count the number of twins born to a group of pregnant women who work in the same office. So there are two categories. They either give birth to a twins or not. We'll have to assume that in the office, the woman who gives birth does not influence the next person who gives birth, whether they're twins or not. So we'll have to assume that they're independent. It tells us in the problem, the probability is 1 out of 90, so the probability of success is always constant. And there is a fixed number of observations because we're talking about the women in the same office. So there may be 10, there may be 12, we're not sure how many women there are, but there is a fixed number. So letter B is binomial. Okay, part C. We count the number of times a woman who has been pregnant 3 times gave birth to twins. This one's a little harder. We have to have some knowledge, and we're also not referencing part B. But the probability that someone gives birth to twins increases if they've already had twins. So in letter C, they are not independent. So if my wife gave birth to twins, the next time she was pregnant, the probability that she gives birth to twins is higher. So they're not independent, and the probability of success changes. So P is not constant. And that one you needed some medical information to be able to answer. Okay, letter D. We pick 40 M&Ms at random from a large bag, counting how many of each color. In this particular problem, there are not 2 outcomes. So there's more than 2 outcomes. So this is not binomial. And then the last question, letter E. The last census found that 26% of all businesses in the United States were owned by women. Suppose that's true for your town. You call 15 businesses randomly from the yellow pages, counting the number owned by women. So there are two outcomes. Either they're owned by women or not owned by women. So there's definitely two outcomes. The probability of success is 0.26. There is a fixed number of outcomes, or fixed number of trials, 15. And we'll assume that they are independent. So this, I would say, is binomial. So the next learning target is going to be about calculating binomial probabilities.